Okay, so today we're going to cover the rest of the content for the simplifying expressions and combining like terms portion of the unit. There will be a test on this stuff probably on Tuesday, but those of you that are quarantined, if you don't feel ready for it, we can always push it back and find another time to do it. Next week, we will have Friday school, so that is always an option as well. But we are getting close to the end of the quarter. This upcoming test will be the last one on first quarter's grade book. A lot of the times when we start doing the algebra unit, kids ask why we are bothering to learn this stuff. We have a whole bunch of letters thrown into math, and we've never really used those before. This is kind of one example. It's a little bit silly, as a lot of math examples are, but it just gives you an idea of how variables can just be used in really common situations. So this is that you and some friends are planning a pizza party. You call the pizza place and buy 7 pizzas, 5 orders of breadsticks, and 10 sodas. One of your friends offers to pay you back for 3 of the pizzas and 2 sodas. Another friend offers to pay you back 4 orders of breadsticks and 6 sodas. Write an expression for how much you pay using P for the price of pizza, B for breadsticks, and S for sodas. So initially, as a group, we're buying 7 pizzas plus 5 breadsticks, which cost B, plus 10 sodas, which cost S. Your first friend offers to pay back 3 pizzas, so you can subtract 3 pizzas, or the cost of 3 pizzas, and 2 sodas. So this will leave us, we can combine these. I'm writing them under them very specifically. So we can write this as 4P plus 5B plus 8S. The second friend offers to pay back 4 breadsticks and 6 sodas. So minus 4B minus 6S. So that leaves us with 4P plus B plus 2S. Now, you'll notice that during this problem, I wrote out multiple different steps and rewrote my equation a couple of different times. So generally speaking, when you're working with expressions like this, a lot of kids are tempted to try to just do all of the simplifications in your head. And as you'll see later in what we talk about today, it's really helpful to be able to write things out. So I would strongly encourage you to use paper and pencil or whiteboards if we're in class or whatever to actually write out expressions as you're simplifying them so that you can see what the variables are changing, what things you can combine, and all that different stuff. So moving on, we've been talking about, I really need to fix this. I realized this today in class that there's a typo in here, so ignore that. We've already worked with combining like terms through addition and subtraction. And we know that when we're adding, we can only add like terms. So if we have 5x plus 3y, for example, we can't do anything with this. It's already as simplified as we're going to get it. So multiplication and division act a little bit differently. And the easiest example to look at here is just what is 4 times x? We know that 4 times x is simply 4x. We just write them next to each other. And it turns out that's kind of what you do when you're multiplying with variables. So when we're multiplying constants and variables, we just multiply numbers and coefficients normally and then keep whatever variable is present. So if we have 4 times 5y, which is part of the notes if you look at those online, we multiply the numbers in here. So 4 times 5, which gives us 20. And then we're just going to write the y. And that's it. We're done. Easy peasy. So then if we have, let's say 3 times 7 times 2x, we do 3 times 7, which is 21, times 2, which is 42. And then we just write the x. So you can kind of just completely ignore the variable for now, right until the very end. So if we have negative 3 times negative 4z, negative times negative gives us a positive, 3 times 4 is 12, so you have 12z. Now, it gets a little bit more complicated when we're using different variables. So if we're multiplying like some x times some y or something like that. However, it's actually not actually changing anything from our perspective. All we're going to do is write the numbers together. So x times y equals x, y. Y times z equals y, z. A times b equals a, b, and so on and so forth. One thing that I did today in class was I asked people what x times y times z is, and then kept telling them they were wrong when they said x, y, z, and instead I wrote it as z, y, x. The point of this is just to let you know that the order of these things doesn't actually matter. X times y times z could be y times x times z or z times y times x, whatever order you put them in. As long as you have the right variables and the right numbers of each variable, then you're totally fine, and it works either way. So now we can look at different variables and actually start bringing coefficients back in. So let's say we have 3x times y. We're going to do 3 times the 1 that would be in front of y, which is just 3. Then we do x times y, which is x, y, and then we're done. So again, nothing too complicated here. Here we've got 4x times negative 2z. We'll do the 4 times the negative 2. It's negative 8. And then we have xz. So again, hopefully nothing too terrible just yet. Here we have 5z times 3x times 2y. So that's going to give us 5 times 3 times 2. 5 times 3 is 15, times 2 is 30. Then we have z, x, y. And again, the order doesn't matter. If you want to write in alphabetical order, go x, y, z. That's totally fine. It is 100% up to you. Now we're going to get into multiplying the same variable. And this is where things get a little bit more complicated. So before class started today, I had kids do warm-ups like this. I asked them to write these in expanded notation. So 4 squared, 3 squared, and 27 squared. And hopefully you remember from our exponents unit, expanded notation just means writing them out as multiplication. So 4 times 4 gives you 4 squared. 3 squared is just 3 times 3. And 27 squared is just 27 times 27. So then I asked the question, well, okay, what is x times x equal to? And they looked at it for a second, and most of them figured out that, well, if a number times a number is just the number squared, then a letter times a letter is probably just letter squared. And that is correct. When we have x times x, we're just going to get x squared. So here's how the exponent breakdown works. We have, let's say, for example, 3x times x. This is equal to 3 times x times x. X times x is equal to x squared, so we can just write this as 3x squared right here. And this would be the simplified version of this. Now, on a quiz or something, if you did write 3xx like this, technically that's not as simplified as we can make it. Having the exponent over our x is actually more simplified than not. So I would expect you to be able to simplify it to this. When we multiply x squared by another x, we can kind of look at it the same way as we did with these up here. So we have 4 times 4, that equals 4 squared. If we add another 4 in here, we don't have to change this number or anything. We just change the exponent and move it up 1. Same thing with the x's. So if we have x squared times x, that just becomes x cubed. We just move the exponent up 1. So multiplying the same variables, we'll do a few practice problems with this. We've got 3 times 6, that gives us 18. X times x, that would be x squared. Here we have 5y times 3y times 2y. 5 times 3 times 2, we already did that, that's 30. And then we have 3y, so we're going to do y to the third. Now, be careful here, because these ones you could also add. So if I had this instead, 5y plus 3y plus 2y, this would just give me 10y, which is obviously a very different answer. So just be careful, you know, whether or not you're multiplying and dividing or whether you're adding and subtracting. When we're adding and subtracting, we can only do it with like terms. When we're multiplying, we can do it with whatever terms we want. So this next one, for example, we have 4x times 3y times 3x. 4 times 3 is 12, times 3 again is 36. And then we have x times y times x. That's 2 x's, so we have x squared, and then a y. And the last one, we have 2x times y times 3x times 4. 2 times 3 times 4, that is 24. Give me a second. We have 2 x's, so we have x squared, and we have 2y, so we have y squared. Circle these. So again, this is getting a little bit more complicated, but hopefully it's nothing too terribly difficult. Now, once we've done this, we can start to look at simplifying really complex expressions. And the expressions right here are going to be probably the second hardest thing on this unit quiz. So if you can do these and follow along, then you're already in a really good spot. And if you can't, that's okay, because this is one of the more difficult things. So we have 3x times 2y. 3 times 2 is 6. We'll have xy. And I'm just going to bring these down, because again, writing these out is going to help us see what our like terms are. So here we have 6xy plus 4xy minus 3x. So obviously we can combine the xy's. 6xy plus 4xy, that's 10xy. And we have a minus 3x. We need to be careful here. Yes, the 10 has an x, or sorry, the 10xy has an x, and the 3 has an x, but these are not like terms because of this extra y variable. On the next one, we have 3z times 5y, that's 15zy, plus 3y minus 6y. For these ones, I'm just bringing it down. Now, looking at this, we can simplify our plus 3y minus 6y. Remember to keep the symbols with them. So we have plus 3 minus 6, that's negative 3. So we should have 15zy minus 3y. Last one, we have 4xz plus, we have 3x times 4z, that's 12xz, minus 4z plus 3z. And you'll notice I'm kind of just naturally going in order of operations. These ones, the multiplication was the first thing. This one, multiplication's over here, but according to PEMDAS, we're going to do multiplication before we do addition. So we need to multiply these out first. Then we have 4xz and 12xz. Those combine to give us 16xz. We have a negative 4z and a positive 3z. That is minus 1z or minus z. And that's how we simplify those really complex expressions. Now, the first practice that goes along with this is combining like terms practice 1. That's already in the Google Classroom. You guys are welcome to work on it online if you can. If you'd rather wait until you get back in person, that's totally fine. There will be paper copies of it. Just remember, the more stuff you put off until you get back, the harder it's going to be to get caught up. So if you can do it at home, this is a good practice. I am in this PowerPoint, though, just going to power through, get done with all the notes. Actually, both classes today in person decided to do that as well. So just get you guys caught up. Tomorrow in class, you won't have any new videos or anything. It's going to be a work day. I will add the, what's it called, combining like terms practice number 2 to the Google Classroom tomorrow as well. But it's just going to cover what I'm about to cover here. So the warm up here, we talked about this as a class. I had everybody vote on whether or not they thought these were like terms. So 4xz and 5zx, these are actually like terms. Again, with multiplication, it doesn't matter what order these are in as long as they're being multiplied. And we have an x, we have a z, we have an x. We have the same letters and same quantities, so this works. Same with this one. So 6xyz and 9zxy. We've got the z, we've got the y, and we've got the x. Now, this one was an interesting one, and this was the first time we had any split votes. So we had 3x squared and 4x. Now, I'm going to rewrite this in the improper, not fully simplified form. And when we do this, we can see pretty quickly that these are not like terms. This has an x, this has an x, and then this one has an extra x. And when you have that extra letter, it's not the same term anymore. So these are not like terms. The next one that's also a little bit complicated is this one. So we have 5x squared y and 3y squared x. Again, if I rewrite these terms in their unsimplified form, it'd be 5x x y and 3y y x. And when we write it out like this, we can see, okay, we have an x in common, we have a y in common, and this one has an x, this one has a y, so these are not like terms either. Now, the important thing to take away from this is, first of all, the exponent in a term only applies to the variable or number it is directly after. So in 2x squared, the only thing being squared is the x. This is 2 times x times x. It is not 2 times 2, which would be 2 squared, times x times x. It's just 2 times x times x. Other than that, though, the actual order of numbers and variables doesn't matter as far as like terms are concerned. So I can have 4xyz or xy4z or zyx4. These are all perfectly fine. That being said, we almost always write numbers at the front of these expressions. It looks really weird when you start putting the letters in front. So just as kind of a keeping things somewhat organized, we tend to put the numbers at the front, tend to put things in alphabetical order, but it's not entirely necessary. And I even tested it in IXLs. You can put them in like this on those and it'll work just fine too. One thing that is important to note here though is like, let's say I have x squared y z. This is equal to something like y x squared z. But if the squared changes, so if I go instead, I still have the squared in the first spot and I go y squared x z, these are no longer the same thing. I now have a y value that's squared instead of an x value, and that makes the term different. So we can combine these two, but we cannot combine this one with those two. If we had another y squared xc thing, we could, but yeah. So we want to simplify these. We'll first look and see which ones are like terms. If you're struggling with this stuff and if it seems like we're getting too confusing, because there is a lot of different things that make terms different, it might be helpful to either take colored pencils or like underline some of your like terms and then put an overline on different terms or something like that. It can help you see which terms you can combine and which terms you can't. So here we have 3x squared, 4x squared, and 3x. Since this one's just an x, we can't combine it. We can combine the other two straight across. So we'll get 7x squared plus 3x. That one's done. The next one, we have a y term, we have an xy term, and then we have a 4x term, which is different. So all three terms here are different. So this is just done. We don't have to do anything to this. We can't simplify it any further. That's as good as we can do. The next problem, 4z squared plus 3z squared plus 5z cubed. Be careful here. A lot of kids thought this was a squared in class. This is in fact a 3, so it is different. We can combine this one and this one. We cannot combine this one. So that'll give us 7z. Oops. Z looks like a 2. Here, I'll put it across through it to make sure it's a z. So 7z squared plus 5c cubed. The last one's a little tricky as well. We have 3x squared y plus 4yx squared plus 3y squared x. So this one has an x squared y. This one has an x squared and a y. This one has a y squared and an x, so it's different. You can't combine that one. So again, we'll have 7 x squared y. Order doesn't matter here. You could write yx squared, up to you, plus 3y squared x. Now, the last thing we talk about in this unit is the distributive property. And some of you might have already seen this if you started on the IXLs. Apparently, they changed them up and started adding in distributive property earlier, which is kind of a pain because last year it was nice and separated, but that's okay. This will help you actually be able to finish this correctly. So this top part is really, really important. We need to know this year. This is going to come up quite a bit, not just in this unit, but in future units as well. When a term sits outside of parentheses containing 2 or more items, it must be multiplied by everything contained within the parentheses. And I'm going to underline this multiple times. This is important. Everything within the parentheses. So for example, if we have 4 times, all in parentheses, x plus 3y plus 2, this 4 is going to get multiplied by x. It's going to get multiplied by 3y, and it's going to get multiplied by 2. And when you're starting out with these, I would strongly recommend drawing these lines out so you can actually see what you need to multiply. 4 times x, that's 4x. 3 times y, that's 12y. And 4 times 2, that's 8. The next one, we have 5 times 3x plus 4. So 5 times 3x and 5 times 4. 5 times 3x is 15x. 5 times 4 is 20. So 15x plus 20. For some reason, when we do this with variables, it tends to trip students up a lot more. I see a lot more just multiplying this once and then not bothering with the other ones than I do when it's a number. Try not to make this mistake. I'm sure that some people will, and that's okay. But try to avoid this. Remember that even if it's a variable, we're still going to multiply it by everything in the parentheses. So in this case, we have x times 2x, that's 2x squared. X times 3y, that's 3xy. And 4 times x, that's 4x. Now, last little note on distributive property. When the number in front of the parentheses is negative, the negative needs to be distributed to each term as well. So basically what you're going to see is whatever the sign is in front of the numbers or letters inside the parentheses, it's going to become the opposite. So we have negative 3 times positive x plus 7. Negative 3 times x is negative 3x. Negative 3 times 7 is 21. So we can still write this as plus negative 21. But then since we're simplifying, this becomes negative 3x minus 21. Now the next one is a little bit interesting. It's 5 minus in parentheses x plus 4. Now we could actually work this out with a couple of different numbers and see what we need to do here, but I think it's a little bit quicker if I just kind of explain. The negative is going to change the signs of all of these. There's not technically a number here, but it's effectively a 1 because this is basically saying negative 1 group of x plus 4. So that's kind of the way you can think about this if this is confusing. So we're going to have negative 1 times x, that's negative x. Still got our 5 here. Negative 1 times 4, it's minus 4. And then I can combine my 5 and my minus 4 and be careful to keep the sign with it. So 5 minus 4 is 1. So we're going to have negative x plus 1. Or 1 minus x, if that works better for you. Again, the order here doesn't really matter. The next one, we have 15 minus x times 3 minus y minus 4x. So again, we're basically multiplying by negative x. So negative x times 3, that's negative 3x. I guess here I'll put my 15 in at the start. Negative x times negative y, that's plus xy. Negative x times negative 4x, that's plus 4x squared. So what you'll notice in all of these is the symbol in front of these changed. So this was a positive x, it's now a negative x. This was a positive 7, it's now a negative 21. This was a positive x, it's now a negative x. This was a positive 4, it became a negative 4, and then we simplified it down to a positive 1. But that's just because we had this positive 5 on the outside already. The next one, we had this positive 3, it became negative 3x. We had a negative y, it became positive xy. And we had a negative 4x, and it became positive 4x squared. So all of those symbols have changed when there's a minus sign outside of our parentheses. So the practice that goes along with this is the IXL X13 and combining like terms practice 2. These will both be posted in the Google Classroom tomorrow morning. The video is a little bit late tonight, but that's okay. You guys will have all weekend to work on this. Chances are what's going to happen is Monday, so tomorrow is going to be a work day. Monday we'll do a little bit of review, and then Tuesday is going to be the quiz for anybody that's ready for it. Those of you that have been on quarantine, if you're not feeling like you're ready by that point, that's okay. We can push it back. And like I said, we have Friday school next week, so we can work on it then as well. If you do have any questions about this, or if you're starting to panic or something, shoot me an email, let me know. I'll do what I can to give you some extra help. And if we need to take more time with this when you guys get back, we can always do that. So don't panic, and I will see you guys later.